Welcome back from the break, everyone. Let's get back to this problem. So I was trying to insert at the tail of the list. We had done a traversal. I'll go through the slides, which are a bit nicer than my drawing. We'll take that away. We had found the tail by going through until we got to current next equals null, because that's the last node. We created a new node, and I used the create node function. And then we connected this last node that current's pointing to up to the new node by saying current next equals new node. Okay, and that's what I've just done in the code. And of course, the drawing I did myself looks a bit like this, but it's the same thing. Now, to see if it works, we've got to actually use the function right in the main, which I didn't do. So in this, I've got a list that I made before with last week, adding it to the beginning. Here I'm going to make a second list, and I'm just going to say insert at tail. This list is called head 2, and I'm just passing in data from this for loop. So I'm just passing in I. So this is going to create a list, and it's going to add 0, then 1, then 2, then 3 to the end of the list. Like, that's what we're aiming to do. Now let's compile it. Oh no. Oh, here we go. Let's compile it and run it. Oh, so it's crashed. So it was fine in the code we did before, but now we're trying to insert elements into this list. This is the code we've just written, and it's crashing. Now, why would it be crashing? Can anyone? Yeah? Ah, so it's not updating the value of what? Yeah, do you mean up here? Well, no, that's correct. That is one. There's more than one problem. You found one problem. The other problem is when we start this, the first time we call this function, we're passing in null. The first time we call this function, we've got an empty list. And actually, you can see that detail in here somewhere. The first time we call insert tail, we've got nothing in our list. We're passing in null as the head of our list. And this is where it's crashing. Now, why would it crash if we pass in null? So right now, our list, the head of it's null. What's going to make it crash? So if head is null, what does current equal on this line? Null. We're saying current equals head. Head's null in this case when we're passing in an empty list. Current's null. What happens if we try and say null arrow next? Because if current's null, that's kind of what we're saying. What happens then? Yeah, it crashes. So anytime you've got a pointer and it's equal to null and you try and dereference it, that's what the arrow does, dereference it. You're trying to go there, go to null and get a value out, your program's going to crash. So we passed in an empty list. An empty list has the head is equal to null because there's no data in it yet. We've set current to have null, there's no data in it yet. And then we say current arrow next, we crash. So this is really common, and you're going to be having your programs crash a lot because of this over the next few weeks. So what we have to do is add a special case. Where's my cursor gone? Oh. Okay, here it is. So over here, before I've even done this, I'm just going to check if if the head of my list is null, this means my list is empty. Then what's going to be, like, what do I do? I'm trying to add a new node to the end of an empty list. Do I have anything to connect it to? Not really. But what's the head of the new list now? Yeah, so now there was nothing in the list, but now I've made a new node, and that's the head of the list. Does everyone agree? So the head of the list was null, there was nothing in the list. I'm trying to add this to the end of the list. I create a new new node. That's now the head of the list. That's the only thing in the list. So if the head is equal to null, I've got an empty list. I can't go and do all this code to find the end of the list or the last node in the list. There's nothing there. It's going to crash. So I can do something like this. And now if I compile this, I've got that special case, and I compile it and run it. It didn't crash, but it didn't really do anything. It didn't print anything out. So it didn't crash. So this part here stopped us from dereferencing our null pointer. But when I go and print my list, oh, I didn't print it. Maybe it is there. I just didn't print it. It's not going to be there though. Let's try it anyway, because yeah, there's nothing there. There's lots of new lines. Yeah, and this was the error that, sorry, I forgot your name actually, that you brought up. We hadn't updated the head of the list. So over here, I've got a variable called head2 in the main on the stack, and it's equal to null. Oops, head2. Right? Does everyone agree? Now, when I call my function insert at tail, I'll be passing in null and say 0 the first time. So let me go down to here. I'm passing that into the function. So my function insert at tail, it's calling it head, but it's getting passed in null and 0, for example. Right? And the data is equal to 0. Now it's going to create a new node, and it will have a new node variable. And again, I'll make up a fake address. And when it's done a malloc in create node, it would have created something on the heap, and it would have put this data in it like this. Right? So in our insert function, I've got a parameter called head. Imagine it's passed in null. I've got the data, it's naught. I've got my new node variable. It's storing the address of this node I've created on the stack. Now in this case, I'm saying, okay, let's make the head equal to null. So, oh, no, I'm not. If the head's equal to null, let's make it to basically point to the new node or be equal to the new node. So I'm changing this in here to have the address that's in new node, which is OXE0. So now head in insert tail is pointing to this new node. All right, is everyone happy? So head in the function insert at tail is pointing to the new node that I've just malloced. Now when this function finishes, all of these variables on the stack don't exist anymore. This malloced node does. It's on the heap. But what does my head2 variable have in it? If you can read it, null. So head2, the original list back in main, doesn't know about any of this. The original list back in main says head 2 equals to null. In insert tail, it did all this stuff. It set it all correctly. But back in the main, it still has that original information, head 2 equals null, and it's never been modified or updated. So what we have to do is we have to return this data. We have to return it and say, actually, this is what the head of the list is now. And by the way, when we put this star here, we're often putting it right next to the function name, but this is the return type. So now we want this function to return the head of the list. So anytime the head of the list was updated, it can let the main know, right? Please update your information. So it's like if you've got my address and I move, I have to let you know so you can update my address. So this function's updated what the head of the list is. In that case, it needs to let the main function know. So now we've got to return the head at the end. And that's not enough. The function needs to do that, and the function's all good. But then when we call the function, we've got to make sure we're not ignoring that return. So if I just compile it now, I'm returning this, but I've still got nothing because I haven't used the function properly. I have to say head 2 equals this. So my function is saying, actually, this is the address of the start of the list now, and I've got to make sure I store that and update the address of the start of the list. So if you don't do all of those pieces, it doesn't work. All right, let's try it. Well, hopefully it does work now, right? It doesn't. Oh, it didn't save. Fingers crossed. Yay. And I'm calling print every time so we can see it's growing. We're adding it to the end. But yeah, the thing is, anytime you might be updating the beginning of the list, which we certainly are if we're starting with an empty list, we're always going to be updating it. You've got to make sure your function returns what the head of the list is now. And you've got to make sure you update it. You actually assign it to your local variable. Okay. Any questions about that? Probably, but you don't know where to start. Okay, so that's adding to the tail. We're going to do another example of inserting something into a list. So this time, the slides go through what we just did. Okay, and then it shows you the final thing. So we've looked at inserting at the beginning and the end. Now we want to be able to try inserting somewhere in the middle. So let's just clear our heads and think about this. So if I've got a list and I want to insert somewhere in the middle, I've got to work out where the middle is. Now, the easiest way to start with is to find out, well, what's the size of the list? If I know the size of the list, then I know where the middle is, at least like a counter. So if this list is size 4, which it is, I'm looking for the node at, say, position 2. I want it to be in position 2 once I've inserted it. So if we think of our positions, and remember, this isn't like an array where the computer knows, oh, here's position 0, 1, 2, 3, but we're going to be counting along. And when we count along in our loop, we're going to call this 0, 1. And if our list is size 4, we want our new node to end up at position 2, because then it will be in the middle. So we find the size of the list, we divide by 2. That's the position we want our new node to be. How do we find the size of our list? No, we can't. Size of will tell us the size of one node. C is not going to know how big our list was. Yep. That's right. The answer was we can loop through it until we get to null and count as we go along. So if we haven't kept track of that ourselves already in a variable or something, we can count through the list. Okay, so that's the first step. Before we can insert in the middle, we have to have a way of finding the middle. This is one way. There are other sneaky ways of getting to the middle of a list, but we'll do it like this. So I've got my list length function up here. And I need to write one down here. So this is returning an int. It's called list length. And the input's just going to be some kind of list. Oops, that wasn't very good. Oh, 24T3. Okay. There we go. All right, so again, we're going to do a traversal. So remember, when we have a traversal, we typically, imagine I've got this situation, I've got a list of size 3. I'm going to have some counter that I set to 0. I'm going to have a pointer called current that I set to point to the head. And then every time I go through the loop, I increment my counter. So, you know, I check my while loop, is cur equal to null? No, it's not. So I increment my counter to 1 and I move cur along. Are we at null? No, I increment my counter, I move cur along. Are we at null? No, I increment my counter and move cur along. I've gotten to the end, but now my counter knows that there were 3 nodes. So we're just traversing the list, but just counting the number of times we go through the loop, because that's how many nodes we have. So I'll make a counter, and I'll make a pointer to a node. I'm going to call it cur, and I'm going to make it equal to the head. So cur is pointing to the head of the list to start with. Now notice, if our list was empty, this function should still work because the condition is cur equal to null or not. That's fine. It can say, yeah, it is equal to null. The loop does nothing, and our count is still 0. So that's going to work. But in the loop, every time we find a node that wasn't null, we add it onto our counter. And then we keep doing our traversal by saying cur equals cur next. Okay. Then at the end, I return my counter. Now, do we think this will work? Does anyone have any questions? Do you want me to go through that code again, explaining what happens? Do you want to do a poll? Can you guys do a poll to see who wants me to go through list length again? Because, yeah, it's important to get this basic thing before we move on to something like the rest of it, inserting in the middle. Yep, question? Do we finish this file with, we still have to go middle? Sorry? Is that the end of the middle part? No, we haven't even started the middle. We haven't started inserting in the middle, but the first step is to find a function, to write a function that can find the length of the list, because then we're going to use that in insert middle. But before we do that, we want to make sure that this function works and is correct. So we should probably test it out. So while I'm waiting for that poll, let's just test it out and see if it works. So we've written something to find the length of a list. I'm just going to shove it in here because I'm printing out lots of lists. Let's print out how big they are before we print them out. Okay. Yep.
If the number, if the size of the linked list is suppose odd, then what do we consider as the middle? Like what?
Okay, so we've got a good question about when we insert in the middle. Yeah, sometimes there's no middle. If you've got an even number of elements in a list, there's no exact middle. So typically we might take just one of those middle items. So if it's the middle to the left or something, that's fine, if you don't care either way. Yep. So with this, let's just check if this length of a list works. Okay, so it's saying that the size of this list is 1, the size of this list is 2, the size of this list is 3, the size of this list is 10. Okay, does it work? Let's just double check. Oops, that's not what I wanted. Yep. So I'm just testing it, and then I'll go through the code again of list length. We just want to check that it did work. Yep, size 0 if we had an empty list. All right. Is everyone clear about what this is actually doing, this function? Just working out how many elements we have in our list. Okay, do you have a question? Nope, okay. So I'm just calling it repeatedly. We had a list with nothing in it. It said size 0, this one, size 1, size 2. Let's go through it again. Let's go through the code. And I might actually draw fake addresses. So imagine I've got a list. Let's start with the basic case. Imagine I've got a list and it says head equals null. My counter is going to end up being, my counter gets set at 0. My car, which is another variable, it's equal to head, car will be equal to null. So this is the null case. We always need to check this works for things. We now say, is car not equal to null? Car is equal to null. So we're not going to go through this loop at all, and we're going to return 0. So for the base case, or the simple case, where we've got nothing in our list is going to be null, car is going to be null, and we're going to return 0. Is everyone happy with that? Okay. Now what if the list isn't null? That's the problem. So imagine the list isn't null. And I've got head, I'll draw it over here. And I've got some list over here. That'll do. Now imagine our addresses are like that. Oh dear. All right, so our list is living at address OXF0. So this is the head of our list. This node here is connected to this node here, so its next field would be E4. This node here is connected to this one, so it would be F4. This one has a null. Okay, so that's our list. Now we've got a counter, and our counter is equal to 0. All right, so we're going to make a variable called char. And char, to start with, equals head. So it's going to have this same address that head does. It's pointing to exactly the same place as head is. So is everyone happy with this line here, what char equals head does? Because that's really important. Char and head are both pointing to the first node in the list. They both hold the address of the first node in the list. Any questions about that? Does that make sense? Okay, so now we get to the loop and we're asking, is char equal to null? Is it not equal to null? Well, if I look at char, it's not equal to null. Char is actually pointing to a node. It's not equal to null. So now we increment our counter. So now our counter is equal to 1. Oops. But I update char. I say char equals char next. Char right now is pointing to this first node. We want to move it along to point to the next node, but char next, this is our current node here. Oops. This is our current node here. Oh goodness, me and this pen. This is our current node here. This is current next. This is the field current next, or char next. That's the address of the next node. We want to move char along to the next node, so we say char equals char next. So this has the effect of changing this address to now have this OXE4. So this is char, this was char next. We're getting that out and putting it in char. Now this means char has moved along and is pointing to the next node. Okay. Now we check again. Is char equal to null? No, it's got the address of some node. So we increment our counter. Our counter is now equal to 2. Is that right? What was it before? And we want to move char along. So we say char equals char next. So it's going to update this to the address that's in here, which if anyone can read it other than me, says OX F4. So now char contains the address of the next element. Oh dear. The next element, which is over here. When we get to here, is char equal to null? No, it's still pointing to a node. It doesn't have the value null in it. So it goes through the loop again. We increment our counter. It's 3. And we say char equals char next. Now at this point, what's the value of char next? Well, char is pointing to this node. So the next field of this node is equal to null. So right now, char gets set to null. It's not pointing to any node in the list. It's done. It's gotten from the beginning to the end. And our counter's at 3. And we return our counter of 3. Okay? So the idea is we're doing a traversal, starting at the end, saying char equals char next, until we get to null. But we're incrementing our counter each time. And that's actually counting how many nodes we traversed through. Okay. Any questions? All right. Let's move on. Now we know that we've got a way to find the length of a list. We want to use that to insert into the middle of the list. Oh, that's not what I want to call it. Insert middle. Okay. All right. So yeah, in this case, we would want our new node to be at position 2. Let's assume we're calling this position 0, 1, 2, 3. We want to insert a new node that will become position 2, right? How do we do that? Well, we can find the size of our list to work that out, and then we want to keep going. We want to traverse through the list until we get to here. So we're calling this position 0, position 1. We want our new node to be at position 2, and for this to become position 3 and 4. So we want our new node in here. We need to stop before we get to that position, because we need to be able to connect this node that will end up being before it to it. So we don't want to go past that node. We want to stop just before it. So we're stopping at -1, that -1. Once we do that, it's just a matter of connecting things up. So we'll probably have a pointer called current that stops when it gets to here. And we need to connect 2 things up actually. This will be our new node. Right, and it'll have some value in there. We want to make the next equal to this one that's going to be after it. What would this be called? So current is this node here. What's this node? Current next, yeah, current next. So we would say we'd want this address 60, which we would get from current next. So the one after the current one is the next one we want after our new node. Okay, then we say, well now actually the next one after current has to change. The next one after current should now be this new node. So we just have to find the right position, create our node, and then just make sure we get these pointers right, but connect these 2 pointers to connect it in. So let's just see it on the slide. So again, I've got some kind of pointer called current, usually starting at the head. And again, I'm using this concept of a counter to work out when I'm one before halfway through the list kind of thing. And I keep going until I get sort of midway and the counter's saying, yep, you're at this one before what would be the midpoint. And this is all this loop is doing, counting if we're up to just one before halfway. And like you said, depending on whether we've got an even size or an odd list, halfway, you know, there might be 2 middles. And as long as we're in one of the middles, we're good. Now we want to connect our new node. It should come after the current node, but before current next. So when we make our new node, we would do it something like this. Now we want to connect this first. We want to connect the new node to current next. We want to put this link in first. Then we want to change this other link. We say current next equals new node. Now if we did it the other way, if I changed this link first and said, okay, current next equals new node. What would be wrong with doing that? Well, so it's saying current next equals new node. Yeah. So what we've done is, I think what you're saying is right. She said it would end up with the address of itself if we just said, if we use the same code. But what we've done is we've lost the rest of this list. There's no variable at this point that has that address of that, you know, OX60, it's gone. We've lost it. We've broken the chain and we've lost that address. Yep.
Why can't we let OX60 below the OX5C? Wouldn't that just connect the link?
If we did what?
If I took the OX60 below the OX5C, but like this
Yeah, so what we want to do is, we want to put this address in here to connect it, but we've lost that address. We can see it on the picture as humans, but in our program, there's no variable anymore that stores that. The variable that stored it was here. So if we overwrite this, we no longer have this in any variable, right? And we've lost it. It's like losing someone's address. It's, unless you go and knock on every single door, look for them, you're not going to find them. So we've got to do it in the right order, and that's often the case when we're working with linked lists, that we've got to make sure we set things in the right order so we don't overwrite something that we need. So we set this first, then we set this. We're saying the next node after new node is, the next node after the current node. Let's go back to here. So this was the current node. This is the next one after the current node. That's going to be the next one after the new node. Then we say the next one after the current node is now going to be the new node. And that slots it in exactly where we want. Now, if we just code all of this up, okay, let's try it. So we want to find the middle index or middle position. So I'm going to use the code I've already written, and I've already tested that code somewhat thoroughly. We're finding the middle. Yeah, so we can divide that by 2, and we're using integer division. Let's let integer division decide what middle is for an even number. It'll be the smaller. All right, so now I've got a current. Maybe I should keep writing the whole word so it matches the slides. I'm starting the current at the end. Now, I said in the thing that the condition we're looking for, I need a counter. And I basically know where I want to stop. I want to stop while counter is less than middle minus 1. Middle's the size on 2. I want to stop 1 before I get to the middle because I need to have the node before it to connect it to. While that's happening, I just keep moving along, incrementing my counter, saying current, next, current equals current, next. So here, this is what I was showing you before. I'll go back. Where I was doing this loop, I initialized my current and my counter, and then I was just moving it along while counter was less than that size on 2 minus 1. So I was finding that node that I want to insert the new node after. Now, once I did that, we wanted to create the new node, and then we wanted to connect it up. So let's try that part. So actually, let's make the new node. No matter what, I'm making the new node. So let's do it up here. Struct node, new node. I'll use my create node function, passing in my data. Oops. For now, I'm just going to set the value to null. I don't really know what this next node value is going to be, but I don't know what that is yet. But for now, I'm initializing it to null until I've worked that out. All right, so when I get to the end, I'm going to do this part where I say this new node next equals current next. Now, does anyone have any questions about this line of code here? How this connects this new node to this particular node here? All right. So it's saying that the next one after this node is the next one after this current node. Okay, so I'm going to say new node next equals current next. So I've put that connection in, right? Now I want to put this connection in and connect this one that's current. I want to connect it to this new node as well. And to do that, I'm saying current next equals new node. So I'm updating this next link to be connecting to the new node. Now, that's it, right? We'll see. Now, to test this, let's actually create the same list that we had in the lecture slides, so we can easily see if we've got it correct. I'm going to make a new list called Excitingly Head 3. It's our third list. I'm going to just create a list first. I'm going to say head 3 equals insert at tail. And I'm just going to make our original list from the slide. I'm going to put 13, then 17, then 42, then 5. And before I get too carried away, I'm going to print it out just to check I haven't done anything wrong. Okay. Yeah, so down the bottom, I've got this list here. With 13, I might just put something to remind us what we're doing. There we go. So I've got, one more thing. Sorry. Okay, I've got this list. And just because we've already done the diagrams, I wanted it the same. And I'm going to insert 9 into this list at the middle. So I'm going to say insert, head 3 equals insert. Okay, I haven't got a prototype, I don't think. That's better. Okay, let's try again. Insert middle. So I'm passing in my current list, which has some data in there actually. And then I'm going to say insert 9 into the middle of this list. Then I'm going to print it. Now we want to see if this works, obviously. Does it work? Yeah. So this was my original list. And I've inserted 9. Is 9 in the middle? Yeah, so that seems to work. What if I do the other case? Let's insert another node. See what happens when we don't have an exact middle, right? If I have one more node, it's going to be an even size list. There's no real middle, but we want it to be one of those middle nodes. Yep, the 23 came in here, which we're calling the middle. That's fine. Now, who thinks this works completely? Do you have a question? Is there anything we should test that I haven't tested? Negative numbers? I think in this case, the negative number will just exist. Like if let's try it. I put a -9 in here. It should still work because nothing is due to the order of the actual data we're storing. But in some cases, that would make a big difference. Like if we're inserting it in ascending or descending order. Yeah? Yeah, we haven't tested because I created a list first. What if we've got nothing in our list? Let's create another list. We should always test for an empty list because this is what can break us. And usually we do start off with empty lists. Yeah, we've got a problem. So it seemed to work fine. We had lists, we were trying to insert in the middle. What if the list we're inserting in the middle of has nothing in it and the head is null? Well, let's go down. It's actually telling us, oops, it's telling us over here that it's on this line here. So, yeah, we're having this case where we would be saying null, arrow next. So we need a special case, oops. So basically if the head is equal to null, which is kind of the same as maybe there might be another situation where the middle is equal to naught. Okay, I'll put both in. So basically if you need to insert it at the beginning of the list, let's put it here. And all right, well, maybe let's just do this case. If head is equal to null, let's just return the new node and say that's the head, right? Or if this is clearer, we could do this. Is this going to solve our problem? Okay, nothing crashed. Is it completely working? I don't think it is. We are running out of time. So let's just try it. Let's do another loop. A loop allows us to try it at lots of different sizes. So I'm going to say head 4 equals insert middle, okay. So this, by doing it like this, we're testing it with a size 0 list, then a size 1 list, then a size 2 list, because maybe there's something weird that happens with a size 1 list. That seems to work, right? Okay. All right, I think that's all we've got time for today, which is probably enough, but does anyone have any questions about this? And one of the main sort of messages is always check for a null empty list. Next lecture, we'll recap this insert middle and do a similar function called insert at index, and then we'll start looking at deletion. Okay. All right, thanks everyone. See you on Thursday.